So in the last video, I did a little bit of review on functions. In this video, I want to do some review on what are called linear equations. So good place to start. What is a linear equation? Well, first of all, it's an equation, meaning you're going to have an equal sign in here. And on each side of the equal sign, you're going to have some mathematical expression. So I don't know, 3x plus 2y minus 7. Sure, and maybe on the other side of the equation, I don't know, x minus 3. Yeah, that'll work. It's an equation because I have an equal sign with mathematical expressions on both sides, and it's what's called a linear equation because each of the terms are the things separated by plus and minus signs. So there's 5 terms here, 1, 2, 3, 4, 5. Each of the terms is either a constant, meaning just a number like the number -3 or the number -7, or what's called a linear term where I have a number times a variable. So like the number 3 times the variable x, the number 2 times the variable y, and the implied 1 here times the variable x. I have 5 terms. 2 of those terms are what are called constant terms, and the remaining 3 are what are called linear terms. And anytime I have an equation where each of my terms is either a constant term or a linear term, I have what's called a linear equation. In this class, we'll have 2 variable linear equations, so the letters that you'll see floating around will typically be x's and y's, and the number that's out in front of an x or a y is referred to as the coefficient of that term. Anyways, it would be good if you could look at something like this and immediately recognize that we have an equation, and not just any equation, but a linear equation by looking at the 5 different terms. It's worth pointing out that this specific linear equation can be simplified significantly. Often the way you'll want to simplify linear equations is by solving for the y. Maybe first I'd add 7 to both sides of the equation. So on the left side, I'd have 3x plus 2y. And on the right side of the equation, I'd have x minus 3 plus 7. In other words, x plus 4. Then I guess if my goal were to get the y all by itself, maybe I'd subtract 3x from both sides of the equation. And that'd leave me with 2y equals negative 2x plus 4. And then finally, if I divide everything by 2, I got y equals negative 1x, or just negative x, plus 2. I started with this linear equation up here, and I simplified it several times to come up with 3 more linear equations, each equivalent to the original one given. I mentioned that often you want to solve for y. If you're curious, the reason you want to solve for y is because when y is solved for, it's really easy to change a linear equation into a linear function. All we have to do is change the y into f of x. Remember, with functions, when we're using the letter x as the input, we want the output to be described just in terms of x's, which is why it was important to solve this equation for y in terms of x. That way my output will be written in terms of those x's. Linear functions are important, but they're not really what I want to talk about in this video. On this video, I want to focus on linear equations. I want you to be able to look at this equation, simplify it to this equation, and recognize that each of these are linear equations just by looking at the different terms. Often in math, when I have an equation, whether it's linear or otherwise, I'm interested in its solutions. All the solutions are values for the different variables that make the left side of the equation the exact same as the right side of this equation. So in this case, since I have 2 variables, x and y, my solutions will be pairs of numbers. For example, the pair where x equals 0 and y equals 2, I think is a solution to this equation. Because if I change all the x's in these equations into zeros and the y's into 2's, both sides of the equation will be equal to negative 3. Look, if x is 0, this is 0. If y is 2, this is 4. And 4 minus 7 gives me negative 3. And if x is 0, 0 minus 3 also gives me negative 3. So 0, 2 is a solution to this linear equation. And you might be like, whoa, how'd you see that so well? Like, that's a lot of math that you did in your head. Well, it's because I didn't look at this version of this linear equation. I looked at this version of this linear equation, where it's a lot easier to see the different solutions because it's been simplified. If x equals 0, 0 plus 2 is just 2, so the y would be equal to 2. In other words, if I put 0 into this machine, the number 2 would come out. That would be my output. But that's just one solution. There's many other solutions, and if you had the desire, you could probably find them. Let's see, 1, 1 is also a solution because 1 is equal to negative 1 plus 2. When I put 3 into this machine, negative 3 plus 2, or negative 1 comes out. So 3, -1 is an input-output pair for this function, and it's a solution to this linear equation. One more? Sure. If I put 6 into this machine, it looks like -6 plus 2, or -4, would come out of the machine. So this is yet another solution pair to this equation and to this equation. I found 4 solution pairs, but so far I just kind of have examples of solutions. I don't have a way to talk about all the infinitely many solutions. But an interesting thing happens when you plot each of these different solution pairs. If I take the point 0, 2 and I plot it on a graph, it shows up right here. If I take the point 1, 1 and plot it on a graph, it shows up right here. If I take a point where the x-coordinate is 3 and the y-coordinate is -1, here's where x is 3, here's where y is -1, that shows up right here on my graph. If I take 6, -4, hopefully you can find that point down here on my graph. And an interesting thing appears to be happening right here. If you look at these 4 examples of solution pairs, they kind of line up. They all fall on a straight line. That's not a coincidence. That will always happen when you have algebraic equations where each of the different terms are either a constant or a number times a variable. If you're wondering why this criterion led to this name linear equations, the linear part of it comes from the fact that the solution pairs always fall in a straight line. They're linear. And that's more than just a nice geometric fact. It allows us to see the infinitely many solution pairs without even doing any calculations. It looks like my graph goes through this point right here that has an x-coordinate of -4 and a y-coordinate of +6. Because I knew these points were on the graph and I recognized this was a linear equation, I know that the orange line represents all the different solution pairs, and since the point -4, 6 is on that line, the pair -4, 6 must be a solution to this equation and to this equation. Linear equations are kind of the most basic type of equation that you'll run across in math, but it turns out they're super useful in a calculus class, maybe surprisingly. So here's a quick review of linear equations, how to recognize them algebraically, and an interesting property that their solution pairs have geometrically.